For this video, we're going to be discussing independent events. So before we can talk about independent events, let's discuss what a compound event is. So a compound event is just when two or more things happen. For example, a compound event could be like spinning a spinner and rolling a die. It's two different things that are happening, okay? And for them to be independent events, it's when those things that are happening do not affect each other. So it's when the probability of one thing happening does not affect the probability of another. So for an example, flipping a coin and rolling a die are independent events because the act of flipping a coin does not change the probability of rolling a die. If you think if I flip a coin, I have two options, heads or tails. And if I roll a die, I have six options, 1, 2, 3, 4, 5, 6. Flipping this coin does not change the probability of what I might get when I roll the die, so they're independent events because they do not affect each other. And some key words to look for are with replacement. If I take cards out of a deck and I put them back in, or if I take marbles out of a bag and I put them back in, the words with replacement will tell you that you're talking about independent events. So, if I want to find the probability of two independent events happening, I just find the probability of each event and then multiply them together. So, let me give you a quick example. Let's say I flip a coin and pull a card from a deck. Okay, so I'm going to flip a coin, and then I'm going to pull a hot card from a deck. I want to know what's the probability of me getting heads and a club. Well, to figure that out, I'm going to take the probability of getting heads and the probability of getting a club, and I'm going to multiply them together. So probability of getting heads, well, my options are heads or tails, so the probability of getting heads is 1 out of 2, 1/2. Probability of getting a club, well, when we talk about suits of cards, there's clubs, diamonds, hearts, and spades. So 1/4 of the cards are clubs, so the probability of getting a club is 1/4. Alright, so this is the probability of heads. This is the probability of club. To find my total probability, I just multiply those things together. 1 times 1 is 1, 2 times 4 is 8, so my probability is 1/8. All I did is I found the probability of each event, multiplied them together, and that gave me my total probability. Alright, so let's do another example. Given the spinner and die below, find the probability of landing on blue and rolling a 5. So I'm trying to find the probability of blue and then getting 5. Well, let's work this out. To find the probability of getting a blue, I'm going to take my number of blue sections, which is 4, divided by my total number of sections, which is 8. 4 eighths, that reduces to 1/2. Alright. Then I'm going to find, so this is blue. Now I'm going to find the probability of getting a 5. Well, there's 1 5 out of 6 total possibilities. That's 1/6. That doesn't reduce. So my probability of a blue is 1/2. My probability of a 5 is 1/6. To find my probability of getting both, I multiply them together. 1 times 1 is 1. 2 times 6 is 12. My probability of getting a blue and then a 5 is 1/12. Alright, they're independent events because what happens on the spinner does not affect what happens to my die. So my probability is just 1/12. Example 2. Given a shuffled deck of cards, Find the probability of drawing a jack and then a club with replacement. All right, so here's how we're going to do this. We're going to find probability, jack, club. All right, so let's think about this. To find the probability of this, I'm going to find the probability of a jack, and then I'm going to find the probability of a club, and I'm going to multiply them together. So, first let's find the probability of getting a jack on the first card I pull. I have 1, 2, 3, 4 jacks out of my 52 total cards. So that's 4 out of 52. And that reduces to 1 over 13. Alright, so now this with replacement is key. Because it means that what I'm doing is I pull a card out of the deck, and let's say it's a jack. Alright, so that card is out. With replacement means, okay, now I put that card back in the deck, so I still have 52 cards. So now I want to find the probability of getting a club. Well, there are 13 clubs out of 52 cards. That reduces to 1/4. So I know my probability of getting a jack is 1/13. My probability of getting a club is 1/4. So now I'm going to multiply those together. 1 over 13 times 1 over 4. 1 times 1 is 1. 13 times 4 is 52. So my probability of getting a jack and then a club with replacement is 1 out of 52. For example 3, it says Robert is running low on clean clothes. Right now he has 3 clean shirts, a red one, a black one, a green one, and he has 2 pairs of clean pants, a pair of jeans and a pair of khakis. I want to know the probability that Robert is going to wear a green shirt and jeans today. So, how am I going to do this? Well, just like before, I'm going to find the probability of each event and then multiply them together. They're independent because what shirt I pick, or what shirt Robert picks, does not change anything about what pair of pants he picks. So, probability of green, well, he has 3 shirts, one of them is green, so the probability is simply 1/3. Probability of jeans, he has 2 pairs of pants, one of them is jeans, so the probability is 1/2. Multiply those 2 things together, and I get 1 over 6. So the probability that Robert wears a green shirt and jeans today is 1/6. So I'm going to leave you with tonight's try it problem. It says if you roll a die 2 times, what is the probability that you'll get a 5 and then an even?